use this part of a table to. So we have been considering several vector differential operations and integrations in Cartesian coordinate. Sorry, I always prefer blue one. Cartesian coordinate is something like this. You have x, y, and z-axis. So change of a coordinate and this is a change of a distance. The major characteristics of a Cartesian coordinate is that the change of coordinate is same as change of distance. So in Cartesian coordinate, not all coordinate system, this is true. For example, probably you have learned polar coordinate. If you are not familiar with the polar coordinate, raise your hand. You never have seen this polar coordinate. You haven't seen this? Never?
I have.
You have. So anybody who is not familiar with the polar coordinate, raise your hand. And Korean probably 국자표계, right? In high school days, even in high school. 수학의 정석? So at this point is x and y, and this is the origin. Distance is defined as square root of x squared plus y squared. This is x, this is y, right? So tangent theta is defined by y over x, or theta is defined by inverse tangent y over x. So polar coordinate is defined by r and theta, right? So assuming that we have point P and point Q, this is R, say delta L theta. So if for change of coordinate, delta theta, change of distance along circumference maybe I should circumference. 원주, right? So what is delta L theta? R delta theta, right? You probably have learned this in high school, in middle school or high school. If you have, it's hard to believe. Let's go back to the circle. Say this is R. What is the total length of circumference? If radius is R, what is the length of a circumference? 원주의 길이 2pi r, right? It's 2pi r. Say this is delta theta. What is the total angle? 2pi, right? Total angle 2pi. So we do not know the distance delta L theta, right? So 2pi over delta theta must be 2pi r over delta theta delta L theta, right? This almost small distance due to the change of coordinate delta theta. Say this is theta. So this small change of theta must be proportional to 2pi r over delta theta. It's same as delta theta over 2pi, right? 2pi is the total angle of this circle. And you're just counting small delta angles delta theta, right? So this delta theta over 2pi must be the same as this distance, delta L theta, divided by total circumference length, 2pi r. So this 2pi cancels each other, right? You can multiply r on both sides. Delta L theta is r delta theta. The change of coordinate is not always the same as change of length. Of course, if you change r to delta r along this direction, then the length is same as the change of coordinate delta r, right? So this distance, delta LR, same as delta r. If you change the change of coordinate along this r, if r is changed from r to r plus delta r, then this differential distance is same as delta r. So delta L theta R delta theta, right? On the other hand, the delta R is same as delta R. So depending on the coordinate system or particular coordinate, the length, change of length is not always same as change of coordinate. So sometimes you need to multiply some factors. So after the Cartesian coordinate, most common coordinate system you're going to use is a cylindrical one. See. So for this system, we are going to use three coordinates. Rho, phi, z. The circular cylindrical system. And somebody can turn on the air conditioning. It's a little bit hot. 누가 에어컨 좀 켜줄래? 약간 덥네. Rho is square root of x square plus y square. Phi is inverse tangent y over x. And z. So rho phi z is a t l rho is t rho, t l phi rho t phi, t l z is t z. There is one coordinate system you're should be familiar with soon, especially if you're taking electromagnetic theory. The next most popular coordinate system is spherical coordinate. Or in Korean, we call it 구면좌표계. So R is square root of x square plus y square plus z square. Theta is cosine inverse z over r. Phi, same as before. Tangent inverse So along the r direction, the change of length is same, right? Delta r over dlr is dr. How about theta? If theta is changing to delta L theta, must be same, right? Yes?
That's from theta is rectangular to spherical, right?
Yes. So let me.
So that's inverse cosine of c over the square root of x squared plus y squared plus c squared.
Right.
Is that correct?
Yeah, that's right. So this total distance from the origin from the surface point,
Okay.
x, y, z, right?
Yeah.
So distance is defined by, can you see this?
Yeah, I can see that. Oh.
So this r must be x squared plus y squared plus c squared. You take the square root. And this theta is actually c.
Right.
So the theta is defined by inverse cosine c divided by r. So this is actually r. You just cut the sphere. Right? Phi is a bit complicated because you have to count the projection of this r into xy plane. So this is theta. This must be pi over 2 minus theta, right? So what is this projection?
Which projection is that?
The projection of r into xy plane. So if we want to calculate the change of distance along this phi, then you have to take the projection of this r into xy plane.
Okay.
Right? So what would be the length? If this is r, this is pi over 2 minus theta, what is this length? Cosine pi over 2 minus theta, right?
Right.
So this distance is actually r cosine pi over 2 minus theta. Is r sine theta, right? So this projection is r delta theta, or dr theta is r d theta. This is a little bit complicated. You have to take the projection of this r into xy plane and then count delta phi, right? So you have to take the projection of this r into xy plane, and it turns out to be this angle is pi over 2 minus theta, right? So actually this distance is cosine pi over 2 minus theta, which turns out to be sine theta. So this distance is actually r sine theta. So can you believe me? So d L phi r sine theta d phi. bit complicated, right? This is very important because you need to take, you need to be able to take, calculate the volume or area. So, if my formula is correct. Yes. To say we have a sphere on the surface, say x, y, z. Delta phi. So what is this area, surface area? On the surface area at R. This is nothing but delta L theta times delta L phi, right? So this is R d theta, R sine theta, d phi. R square sine theta, d theta, d phi. This is small differential surface area. So total surface area, you can calculate the total surface, right? Total surface area is just nothing but you integrate 0 to pi to d theta, 0 to 2 pi d phi, r square sine theta. So there is no, so 2 pi r square, 0 to pi, sine theta d theta. If you integrate, you get minus cosine theta, right? 2 pi r square minus cosine theta, 0 to pi. Cosine pi? Minus 1, right? So 2 pi r square minus 1 plus 1, 4 pi r square. So do you know if you have a sphere with a distance, the radius r, what is the surface area?
4 pi r squared.
4 pi r square, right? You already know that, right? Probably in high school days or in freshman calculus. How about volume? If the total length is big R, anybody remember the volume? 4 pi over 3 R cubed, right? If your memory rings a bell. So that's actually easy. You just integrate one more variable. Total volume is from 0 to R, 0 to pi, 0 to 2 pi, R square, sine theta, d theta, d phi. And of course, dr. You just need to, I'll draw another picture. This is R. And you have another R, dr. So you have surface, not cube, something like this, right? So this delta dr. So this is the volume element that you need to integrate. So we already obtained 4 pi r square, so you just need to do this. 4 pi r square dr. 3 over 4 pi r cubed. I think somewhere through your lifetime you have done this before. No? You haven't done that? But somehow you know this result, right? If you have a volume of a sphere with the total radius of big R, then your volume must be 4 pi r cubed divided by 3. Probably you knew already this result. But you never have derived this before? First time? Simple coordinate. Just simple coordinate manipulation. You can get the surface area and volume element of Alice's sphere. In general, there are 16 other coordinate systems, and 16. Total 19 coordinate systems so far known to us. But probably this is only the coordinate system we are going to learn during this semester. Maybe one more, but I'm not so sure. So before I proceed, if you have any questions. So this manipulation of coordinate system is very important because we are going to do with a more complicated form like a vector differential operator, how to express curl, gradient, or divergence in different coordinate systems, because it looks like if we derived everything for Cartesian coordinate, right? But for that coordinate system, the change of coordinate is the same as the change of distance every time. But we have already seen that some cases where the change of coordinate is not always the change of distance. And when we derive gradient, curl, divergence, we need that information. So in order to move to the next stage, you must feel comfortable handling this. How to calculate surface area, how to calculate the volume element. So this is about the time if you want to stop and ask a question, because the next stage is a bit more complicated. Yes?
You said 19 coordinate systems, right?
Right.
And you said 16 are known?
It's already known.
Okay. What's with the other three?
Ellipsoid?
I don't know.
Okay.
The
For
other
you-
three are orthogonal?
Something like, instead of a circle, we have ellipsoid.
Okay.
So this is a square x square plus b square y square is 1. So when a and b are equal to 1, it's circle.
Right.
But a and b can be different,
Right.
like a football ball,
Yeah.
right? So we can form this kind of coordinate system. It's ellipsoid. It's one of the popular coordinate after the spherical coordinate. But I'm not so sure whether we have time to cover this. Probably you don't want. It's much more complicated than spherical coordinate. But we are going to cover the general method. That will include every other 16 coordinate. You can, in general. So let's say something like this kind of coordinate system. Say Q1, Q2, Q3. Only one condition. At locally, they are mutually perpendicular. Q1, Q2, Q3 are locally perpendicular. So we have general like Q1, Q2, Q3 are coordinate. When Q1 is changing, say, how should I throw this? Q1 to Q, delta Q1. Somehow, the change of coordinate at some position, say, delta L Q1 is H1 delta Q1.
H1 is height?
Some scaling factor,
Scaling factor.
right? Sometimes we call metric. If you take a look at the differential geometry book, let me see. Oops. Oh my goodness. One of my students just got positive COVID. Not this guy. The guy who used to be sitting here last week. So I guess it was week before, and he was tested positive today. I hope everything is okay. I haven't seen him for at least 5 days, so I think I should be okay. I hope. So H1 delta Q1 has a dimension of distance. The same goes for delta L Q2 is H2 delta Q2. So you need to draw something like this. Some distance. So this is delta L Q2 This is delta L Q1. This must be delta L Q3.
This is triangular, or how is that? What's the name of that system?
Curvilinear.
Curvilinear?
Curvilinear. Good. So maybe you want to put general. So every 19 coordinate system can be actually represented by this form. So when H1, H2, H3 are all 1, you obtain Cartesian coordinate, right? So in general, we have delta L1 is H1 delta Q1, delta L2 is H2 delta Q2, delta L3 is H3 delta Q3. Or if you want to put Q1, maybe it's better, right? Q1, Q2, Q3. So special example, Q1 is X, Q2 is Y, Q3 is Z, HQ1 is 1, HQ2 is 1, HQ3 is 1. What do we get? Cartesian coordinate, right? This is one example. If Q1 is R, rho, Q2 is phi, Q3 is Z, HQ, just wait. One is 1. HQ2 is rho. HQ3 is again 1. We all have circular cylinder, right? And Q1 is R, Q2 is theta, Q3 is phi, H1 is 1, H2 is R, H3 is R sine theta. What do we get? Spherical coordinate. And the rest of the coordinate, you don't want to know. Okay? They're complicated. Maybe, if I'm inclined, I will let you know about the ellipsoid or prolate or prolate spheroid or parabolic, etc., etc. Usually, 3 more coordinates are mainly used for designing like a stealth airplane, like a stealth jet plane. You need a very intriguing geometrical structure to make the radio waves, microwave, reflected randomly so that you cannot be detected. In order to want to design those things, like how to design the wingspan or intake or other things, you need a more coordinate system. And in general, these days, just use numerically. The computational coordinate system is most widely used. But basics are the same. So you only need to know this how to obtain the curve, gradient, or divergence, and curvilinear coordinate systems. And most easiest way is using is easiest to define. Gradient is the ratio of the distance between the ratio of the functional change. So gradient of some function is defined by normal direction in Q1 direction divided by delta L Q1 delta F eventually you want to take the limit. Delta Q1, delta Q2, delta Q3 all goes to 0, right? So this is basically Q1 over H1 round Q1 round F, Q2, H2, HQ1, HQ2 round Q2 round F, Q3, HQ3 round Q3 round F. So example, gradient of F, X, Y, Z, X round X round F, Y round F, Z round F. Circular cylindrical coordinate, rho, phi, Z, unit vector in the R direction, rho direction, partial rho, partial F, phi direction, rho, partial phi, partial F, Z direction, round Z, round F. And spherical coordinate, R, theta, phi, theta, R, round theta, round F, phi, R sine theta, round phi, round F. So you want to know which is the normal direction, for example. This is our unit direction. Theta, this is theta. So theta is increasing theta. Phi, this is phi, so this is phi. So you can define that way. Or in Q1, Q2, Q1, Q2, Q3, this is Q1, Q2, Q3. So this must be Q1 direction. So this is Q2 direction. This is Q3 direction. So you can locally define the mutually perpendicular normal directions in curvilinear coordinate. I think if I want to cover curl and divergence, it will take more than an hour. And you have spent already an hour and a half to taking a quiz. So I'm suggesting stopping here today and continue next week. What do you think? If you like to cover more, I can do, of course. You want to stop here? All right. So, bon appetit. Bon appetit means good taste, nice taste in French. Have a nice lunch.